Hi everyone, how are you? This is Rana Sir. Welcome to our Rana Sir educational channel. Today I will talk on a topic whose name is center of mass. In this topic, I will explain its concept in detail and then I will also solve some numericals and the concept of center of mass I will apply in that numerical. Therefore, you concentrate on this live video from starting to end to update your knowledge on this topic. So simultaneously, you also like this live video and also you share this live video with your colleagues, friends and students. They can also update, that is improve and develop their knowledge on this topic. Okay, now one additional information I am going to tell you and you have to follow it positively, properly and safely, and then you write all information on your notebook. So first of all, you have to take one notebook, one pen, and then you have to sit at your location positively, properly and safely to write all data which are available on the blackboard and also those informations which are spoken by me. Okay students, so you concentrate here. I am going to start this live video positively. Now this is the class 11th physics, that is in both language, that is in English and Hindi medium. First of concept I will explain into in English, so students who are reading in CBSE board and also those students who are reading in Hindi medium and also English medium, those students can understand its concept in detail. And after explaining in English, then I will also translate all those information into in Hindi. So student who are reading in Hindi medium or student who are reading in UP board, those students can understand its concept in detail. Okay, now here it is also based on NCERT pattern. It means that numerical and also concept I will not repeat many times, that is in one time. So we have to follow that NCERT concept. Okay, now here topic I have already written here, center of mass of system of n particles. It means that first of all I will explain the concept for one object and then I will generalize, and after generalizing then I will explain the mass of center of mass of a system of n particles. So that concept I will generalize for n term and then I will explain that concept also. Okay students, so you concentrate here. I am going to explain the concept of center of mass of n particles. First of all, I will explain the center of mass of a particular particle and then I will generalize. After generalizing, then I will also explain the concept of center of mass of a system of n particles. Okay, so you concentrate here. I am going to explain it. Suppose that I have to take one object and that object is has a shape like this way. Okay, so this is the object, and this object has a shape like this way. So where will be its center of mass? Suppose that I am saying this object will be as this type. Now here I have to calculate center of mass of the drawn object. Where will be its center? Because total is a mass, but this mass will have a particular center, and that center is called center of whole mass. So I will say this is the mass of an object. So I suppose that center of mass will be at this point. Suppose I am supposing, so its concept I will explain. So center of mass means around that point, center means a point, around that point that total mass will rotate with balanced. It means that whole mass of a body will be at a fixed point. Around that point, that object will move freely. Therefore, we can say that that object has each and every particle inside that is balanced at that point. So that such type of point is called the center of the mass of a particle. Okay, now suppose another information I am also going. If one or more than one forces which are acting on a object, suppose that here I am considering force F1. Similarly, other force I will consider here F2. Next force I will take here. Suppose that here I am taking another force, that is F3, and so on. I can take another force, that is X4. Similarly, more than one, that is N force I can take. After taking, so concept will be as all external forces which are acting on a particular mass of a object. So all force will tend toward a single point, and that point is called the center of the mass. So all force will tend at a point, and that point is called the center of the mass. So similarly, I can explain here properly. So each and every force will act inside. Each and every force will act inside towards a point, and that point I have to say that is the center of the given mass. So it will also point to a fixed direction, and that will act a certain point. So that point is called the center of the mass. Okay, now here I have considered a mass. So each and every mass will have a fixed point, and that point is called the center of mass. Around that point, whole body will move. Whole body will move, and each and every particle of the object will combine each other and balanced when moving along that center. So that center is called the center of the mass. If any external force, one or more than one forces which are lying on the object, that is on the mass, so the direction of each and every forces will tend to a fixed point, and that point I will say the point, and that point is called the center of the mass. Okay, student. So this is the required information how we have to calculate its meaning. So center of mass can be defined as, okay, so center of mass, if we have to write, so I will say, if there are 1, 2, 3 and 4 forces which are acting on the object which has mass, so all external forces will point to a single point. So that single point is called the center of mass. Around that point, all whole object will move. It means that each and every particle inside the mass will be balanced. So such type of phenomena is called the center of the mass. Okay, student. So it is very easy, and we have to calculate center of mass of one or more than one body according to this way. Okay, student. So now I am going to write its definition properly, and then after writing its definition, I will also translate all these informations into Hindi. So student who are reading in Hindi medium or student who are reading in UP board, those students can understand its concept in detail. Okay. Now if I will say, if any person which is available, so what is the center of mass of that body? So I will say there is a point on the stomach, and through that point whole object will move. So each and every part of the body will be balanced. Okay, so that point is called the center of mass of the person. Okay, so all these information, first of all I will write its definition, and after writing its definition I will also explain its, that is I will also translate all those informations into Hindi. So student who are reading in Hindi medium, those students can also understand its concept in detail. Okay, students, so you concentrate here. I am going to explain definition of center of mass. Here I will write definition of center of mass. Definition of center of mass. Now here I will say there is a point, there is a point, with that point whole mass will rotate freely. That is each and every this is the mass. Each and every particle inside the mass are balanced. BALANCED, are balanced. And also one or more than one forces one or more than one forces one or more than one forces which lie on the mass so all forces will tend all forces shall tend towards a fixed point. That fixed point is called center of the mass. Call the center of the mass as shown in figure. Okay, so all the information about the center of mass I have explained here clearly. Okay, now here I have taken one mass, and this mass will have a fixed point, and with that fixed point whole object will move freely, and more than one forces which those lie on the surface of the same mass. So all force will tend inside a fixed point, and that fixed point is called the center of the mass of the given body. Okay, so this is the required concept how we have to calculate the center of mass of a given object. Okay, so this is the required way, and with this way I can calculate its center of mass clearly. So its diagram and I have written like this. Okay, so this is the diagram and this is its definition, so you have to follow it positively. Now you concentrate here. If you are understanding clearly, so you like this live video, and also you share this live video with your colleagues, friends and students, so that they can also update their knowledge on this topic, and simultaneously you also subscribe this educational channel more and more. Now I am going to translate all these informations into Hindi, so students who are reading in Hindi medium, those students can understand its concept clearly. Okay, now सेंटर ऑफ मास मीन्स द्रव्यमान केंद्र। द्रव्यमान केंद्र की मीन्स यह होता है कोई भी द्रव्यमान, कोई भी ऑब्जेक्ट है, वो ऑब्जेक्ट जो होता है एक द्रव्यमान रखता है, तो वह द्रव्यमान जो होता है उस द्रव्यमान का एक केंद्र होता है, उस केंद्र के परितः वो ऑब्जेक्ट जो होता है टोटली जो होता है फ्रीली जो होता है मूव करता है। इसका मीनिंग यह होता है कि उस मास के अंदर जितने भी पार्टिकल का हिंदी होता है कण, जितने भी कण होते हैं वो सभी कण जो होता है फ्रीली जो होता है उस पॉइंट के परितः जो होता है रोटेट करता है। तो उस पॉइंट को हम द्रव्यमान केंद्र करते हैं और इंग्लिश में सेंटर ऑफ मास करते हैं। लेकिन यह भी इंफॉर्मेशन है कि उस मास पर अगर एक या एक से अधिक फोर्स एक्ट कर रहा है, उस पर काम कर रहा है, तो उस सभी फोर्स का जो डायरेक्शन होता है उस फोर्स के डायरेक्शन जो होता है, इनसाइड एक बिंदु होता है, उस बिंदु पर सभी फोर्स जो होता है टेंड करता है, वहां पर जाकर मिलता है, तो उस फिक्स बिंदु को ही हम सेंटर ऑफ मास कहते हैं। ओके स्टूडेंट्स, सो ऑल दीज इंफॉर्मेशंस आई हैव रिटन इन द diagram. Okay, so all these informations which are available in the diagram already I have written in English. Okay, so you have to know clearly. तो किसी भी द्रव्यमान का सेंटर जो होता है, एक बिंदु होता है, उस बिंदु के परितः जो होता है पूरा का पूरा ऑब्जेक्ट जो होता है फ्रीली, बिना किसी अनबैलेंस के जो होता है फ्रीली रोटेट करता है, उस पॉइंट को सेंटर ऑफ मास कहते हैं। और उस ऑब्जेक्ट पर जितनी भी फोर्स, एक्सटर्नल फोर्स माने बाह्य फोर्स जो होता है कार्य करता है, बाह्य बल कार्य करता है, लेकिन सभी फोर्स का जो डायरेक्शन होता है एक बिंदु पर फोकस करता है, उसी बिंदु को जो होता है हम द्रव्यमान केंद्र कहते हैं या सेंटर ऑफ मास कहते हैं। ओके स्टूडेंट, आई होप दैट आप इस कंसेप्ट को आप क्लियरली समझ गए होंगे, इसलिए इस वीडियो को ज्यादा से ज्यादा लाइक करें, शेयर करें अपने कलीग के साथ, फ्रेंड्स के साथ और विद्यार्थियों के साथ, ताकि उनका भी नॉलेज इस पॉइंट पर अपडेट और डेवलप हो सके। और साथ ही साथ इस वीडियो को ज्यादा से ज्यादा सब्सक्राइब करें। और ये सभी इंफॉर्मेशन को एक्सप्लेन करने के बाद से, और इसमें जो होता है इस एक पार्टिकुलर ऑब्जेक्ट मीन्स एक पार्टिकुलर वस्तु के द्रव्यमान का सेंटर ऑफ मास, दैट इज द्रव्यमान केंद्र हमने कैलकुलेट किया है। इसको जनरलाइज करके हम एन पार्टिकल्स मीन्स एन ऑब्जेक्ट के सेंटर ऑफ मास को कैलकुलेट करेंगे। और उसके बाद से इस कंसेप्ट को जो होता है हम न्यूमेरिकल में कैसे अप्लाई करेंगे, उस अप्लाई करने के बाद से उस क्वेश्चन में जो रिक्वायरमेंट होगा दैट इज सेंटर ऑफ मास, उस निकाय का सेंटर ऑफ मास हमको कैलकुलेट करना रहेगा, तो हम उसको सेंटर ऑफ मास कैलकुलेट करेंगे। ओके स्टूडेंट, आई होप दैट यू आर अंडरस्टैंडिंग ऑल दीज इंफॉर्मेशंस क्लियरली। इफ यू हैव एनी डाउट, अगर आपके पास कोई भी डाउट है या कोई भी क्वेरी है रिलेटेड टू दिस टॉपिक, तो यू टाइप या write in the comment section positively your query and then you send. After sending, I will analyze, that is I will study your query and then I will give the appropriate solution of your question, that is of your query in detail. Okay students, so you have to follow it positively. Now I am going to erase this definition and also its diagram, then I will generalize. And after generalizing, I will explain the information about n particle, that is about n objects. Okay, so I am positively going to erase it, and after erasing, I will generalize, and then after generalizing, I will give its center of mass, and then I will also solve numericals which is based on this topic. Okay students, so you concentrate here and you understand all informations. If you are understanding, so you also positively write in your notebook positively for further revision. Okay students, so now we have to calculate center of mass of system of n particles. Okay, suppose that here I am going to draw x-axis and also y-axis properly. Okay, so here I am going to say this is the x-axis. So you concentrate here, because if you will understand the diagram, so your concept will be clear, because with the diagram I will write all informations in detail. Okay, so here I have taken one x-axis and other is y-axis. Now if these two axes will cut, so I will get a right angle triangle. Now the intersection point I will say that is the origin, and its coordinate will be 0, 0. But we have to take here 3D. So here I will explain about 3D. So its coordinate I can write 0, 0. X coordinate, y coordinate and z coordinate will be 0. Okay, now here I have to take several points. Here I am going to say this is the point A and its coordinate will be x1 comma y1 comma z1. Similarly, I will take another point B, and its coordinate also will be x2 comma y2 comma z2. So you concentrate here because I will explain its concept in detail. Now here I will say a b, and then here I will say the point a b c. Here I will write the center of mass. Here I have to calculate center of mass. So center of mass I have to write here xcm comma cm stands for center of mass, ycm and zcm. Okay, this is the center of mass. Next point I will consider here point. Suppose that here I will take point D. Here I will take point Z. So here I will say the x coordinate will be xn comma yn comma zn. Okay, there are n point I have taken on a on the xy plane. I have taken n point on the xy plane. Okay, so its center of mass will be on this straight line which is joining from A to B, B to C, C to up to Z. Okay, now its coordinate I have written here x1 comma y1 comma z1. Similarly x2 comma y2 comma z2, and so on. But I have taken its center of mass that will be here. I have written x suffix cm. Cm stands for center of mass. So here I am saying x coordinate is xcm, y coordinate is ycm, and z coordinate will be zcm. This is the center of mass. Okay, now all these points I have to join with the origin. All point I will join. After joining, I will get n vectors. I will get n vectors. Here I am saying z will be like this. Here z will be here. Okay, so I have to join all these vector. So this vector I will say this is the position vector, that is r1. This is the position vector r2, and this is the position vector rn, and this is the center of mass, that is rcm. RCM, that is the center of mass. Okay, now its direction I have already indicated here. Its direction I have indicated here. Now we have to calculate the center of mass of these n particles. We have to calculate the center of mass of n particles. So center of mass I can calculate by using the concept, that is here I have to write center of mass of r1, vector r1, that will be as we can write, that is in general I have to take center of mass rcm, which is now this object which has mass m1. Similarly I will say this object has mass m2, and this object has mass because we have to calculate its center of mass. Similarly I will say this object has mass mn. Okay, so possibly I have to calculate its value mn. So center of mass I have to calculate r1 x1 plus r2 x2. Here I will write like this: m1 r1 plus m2 r2 plus dash dash. I will write here mn vector rn. because here vector r1 I have written as vector r1 I have written as x vector I cap, y1 vector j cap, z1 vector k cap. Similarly, vector r2 I have written here x2 vector I cap plus y2 vector j cap and z2 vector k cap. If you are understanding all these informations, so you like this live video and also you share this live video with your colleagues, friends and students so that they can also update their knowledge on this topic. And simultaneously you also subscribe this educational channel more and more positively. Now similarly I will say it will be up to n, so I will write xn which is equal to x n vector I cap, similarly yn vector j cap plus zn vector k cap. Okay students, so you have to concentrate on these informations because this is very important, because if you will understand, so concept and formula will be easy to remember and will be easy to apply in the numerical. Okay, so I have written, so center of mass will be like this, divided by, here I have to write m1 plus m2 plus m3 plus up to here I will write mn. Okay, so now further I am going to summarize above. So above I will write summation of I which is equal to I is equal to 1 and up to n. Now here I will write m I into r I. Okay, I have to write here, and this in the left hand side I have to write here cm, rcm. Okay, so rcm, that is the center of mass of n particles. rcm is the center of mass of n particles, and divided by this term I have to also write sigma I is equal to 1 to n, and its value is written here only m1 to m1 m plus m2 plus m3 plus m4 up to mn. So here I will write like this. Okay, this is the complete information. This is the complete information. I have generalized the formula for calculating center of mass. Okay student, now further in the place I can substitute capital M, and then I will simplify. After simplify I can write its another formula, that is in the place of sigma I is equal to 1 to n mi, whole value I will write capital M, and capital M which is equal to cm which is equal to sigma I is equal to 1 to n mi into ri. Okay, this is the center of mass of n particles, and I have taken n particles, that is one particle which is available at the point A, at the point B, at the point Z. Up to here I have taken dotted. So I have to take n particles, and we have to calculate. We have to calculate here center mass of each particle. So center mass of each particle can be given by this formula, that is RCM, which is equal to like this: m1 r1 plus m2 r2 plus m3 r3 plus up to mn rn divided by m1 plus m2 plus m3 plus up to, I have to write up to mn. Now above sum I have generalized here, and below sum I have also generalized here. So each and every student has to follow this concept to get the center of mass of n particles, more than one particles. Okay student, so this is the required concept, and you have to understand all these informations clearly. If you are not understanding, so you also type या write information in the comment section positively, and then you have to send it, and then I will get your information, and then I will study, and after studying I will give the appropriate solution of your query. Okay, and if you are understanding all those informations clearly, so you like this live video, and also you share this live video with your colleagues, friends and students, so that they can also improve their knowledge on this topic. Okay, now all these informations I have to also translate into Hindi, so students who are reading in Hindi medium, those students can also understand this concept in detail. Okay, now यहाँ पर कहा गया है कि सेंटर ऑफ मास ऑफ सिस्टम ऑफ एन पार्टिकल्स, इसका हिंदी यह हुआ कि एन कणों के निकाय का द्रव्यमान केंद्र। यहाँ पर एन कण दिया गया, एक कण जो होता है बिंदु ए पर रखा गया है, दूसरा कण बिंदु बी पर है, और इसी तरीके से जो होता है एन कण जो होता है बिंदु जेड पे है। इसके बीच में बहुत सारे कण हैं, जो कण मिसिंग है वो इसी में अवेलेबल है। इन सभी कणों को जब हम मिलाते हैं तो एक लाइन मिलता है, उस लाइन को जो होता है सेंटर ऑफ मास जो होता है उसी पर कहीं एग्जिस्ट करेगा। तो उस सेंटर ऑफ मास को कैलकुलेट करने के लिए हमने एज्यूम किया है एक वेक्टर आर सी एम है। सी एम स्टैंड्स फॉर जो होता है सेंटर ऑफ मास, यहाँ पर आर जो होता है वह एक वेक्टर है। उस वेक्टर के थ्रू जो होता है हम सभी कणों का सेंटर ऑफ मास कैलकुलेट कर रहे हैं, एक्स के कोऑर्डिनेट के रूप में, वाई के कोऑर्डिनेट के रूप में और जेड के कोऑर्डिनेट के रूप में। ओके, कोऑर्डिनेट को हिंदी में निर्देशांक के नाम से जानते हैं। ओके, तो जो बिंदु ए पर जो कण है उसका जो एक्स इसका कोऑर्डिनेट पॉइंट है, उस कोऑर्डिनेट पॉइंट को x1, y1, z1 इसको वेक्टर, चूंकि ये जो था पोजीशन वेक्टर है, ये जो होता है पोजीशन वेक्टर है, जो जीरो से जो होता है जो भी वेक्टर जो होता है ओरिजिन से पास होता है उस वेक्टर को हम पोजीशन वेक्टर के नाम से जानते हैं। इसलिए वो ए जो होता है वो पोजीशन वेक्टर है, वो r1 के बराबर हो। इस पोजीशन वेक्टर को लिखने के लिए हम जानते हैं किसी भी वेक्टर को लिखा जाता है तो प्रत्येक जो घटक होते हैं x घटक, y घटक और z घटक, इसको हिंदी में कंपोनेंट के नाम से जानते हैं, x कंपोनेंट, y कंपोनेंट, z कंपोनेंट। इसको जो होता है वेक्टर के रूप में फॉर्म में हम लिखेंगे x1 वेक्टर i कैप। इसका मतलब यह यूनिट वेक्टर होता है जो x एक्सिस के एलांग पाया जाता है। उसी तरीके से y1 जो होता है y एक्सिस के एलॉन्ग जो होता है एक यूनिट वेक्टर j है। उसी तरीके से z एक्सिस के एलॉन्ग जो होता है एक यूनिट वेक्टर k है। तो इन x1, y1 और z1 ये जो होता है करस्पॉन्डिंग वेक्टर का कोफिशिएंट हिंदी में गुणांक के नाम से जानते हैं। इसी तरीके से पॉइंट बी पर जो पार्टिकल है उस पार्टिकल का जो कोऑर्डिनेट दिया, कोऑर्डिनेट दैट इज निर्देशांक दिया गया, उस निर्देशांक को जो होता है हम पोजीशन वेक्टर के फॉर्म में यहाँ पर लिखे x2 वेक्टर i कैप प्लस y2 वेक्टर j कैप प्लस z2 वेक्टर k कैप। इसी तरीके से जो n पॉइंट है उस n पॉइंट का जो कोऑर्डिनेट दिया गया है xn yn zn, और इसको जो होता है हमने वेक्टर के फॉर्म में लिखा है वेक्टर n। जो rn जो लिखा गया ये भी एक पोजीशन वेक्टर जो nth टर्म पर है, उसको हमने लिखा है वेक्टर के फॉर्म में xn वेक्टर i कैप प्लस yn वेक्टर j कैप प्लस zn वेक्टर k कैप। तो सभी पोजीशन वेक्टर को हमने लिखा, लिखने के बाद से इनका सेंटर ऑफ मास हमने कंसीडर एज्यूम किया है कि एक सेंटर ऑफ मास इसी लाइन पर, इसी स्ट्रेट लाइन पर किसी भी पॉइंट को होगा। हमने उस पॉइंट का नाम दे दिया सीधे। आप कोई भी जो इसमें अवेलेबल नहीं है उसको आप यहाँ पे यूज कर सकते हैं, वो कैरेक्टर या सिंबल आप यूज कर सकते हैं। इंग्लिश में कंप्यूटर के लैंग्वेज में कैरेक्टर के नाम से जानते हैं, और इंग्लिश लैंग्वेज में जो होता है अल्फ़ाबेट, उसमें अल्फ़ाबेट जो अननोन है इसमें नहीं अवेलेबल है उसको आप यूज कर सकते हैं। और उसमें एक्स कोऑर्डिनेट को xcm लिखे हैं, वाई कोऑर्डिनेट को ycm और जेड कोऑर्डिनेट को zcm के नाम से रिप्रेजेंट किए हैं। यहाँ सीएम जो होता है स्टैंड होता है, इसका मीनिंग होता है सेंटर ऑफ मास होता है। एक्स कोऑर्डिनेट का सेंटर ऑफ मास, वाई कोऑर्डिनेट का सेंटर ऑफ मास और जेड कोऑर्डिनेट का सेंटर ऑफ मास हम वेक्टर के फॉर्म में लिखे हैं एक्स सीएम विच इज इक्वल टू m1 r1 प्लस m2 r2 प्लस m3 r3 डिवाइडेड बाई जितने भी मासेस हैं, जितने भी पार्टिकल्स हैं, उन पार्टिकल के सभी मास को क्या किया है, ऐड किए हैं, m1 प्लस m2 प्लस m3 प्लस अप टू mn। अब इसको जो होता है मैथमेटिकली समराइज किए हैं। यहाँ पर एक पैरामीटर m1 है, दूसरा पैरामीटर r है। तो m1 1 से जो होता है n तक रिप्रेजेंट होता है, 1 से लेकर n तक, इसलिए mi ri लिखे और i को मूव कराए 1 से लेकर n तक, तो इसका समेशन मिल गया। उसी तरीके से यहाँ यम जो होता है स्टार्ट होता है 1 से लेकर n तक, इसलिए यम आई लिखे और i को मूव कराए 1 टू n। इसी तरीके से इस टर्म को जो होता है हमने इस तरीके से जनरलाइज करके लिखे हैं। और लेफ्ट हैंड साइड में आरसीएम होता है, जो एक्स कोऑर्डिनेट, वाई कोऑर्डिनेट और जेड कोऑर्डिनेट जो होता है, इन सभी मास का सेंटर ऑफ मास इससे मिल जाएगा। ओके स्टूडेंट, आई होप दैट यू आर अंडरस्टैंडिंग ऑल दीज इंफॉर्मेशन क्लियरली। ये सभी इंफॉर्मेशन आप क्लियरली समझ गए होंगे, इसलिए इस वीडियो को ज़्यादा से ज़्यादा लाइक करें, शेयर करें, सब्सक्राइब करें और अपने कलीग्स के साथ, फ्रेंड्स के साथ और विद्यार्थियों के साथ, ताकि उनका भी नॉलेज इस पॉइंट पर अपडेट और डेवलप हो सके। अपडेट और डेवलप होने का जो पॉइंट है सेंटर ऑफ मास, अगर ये मास अगर दिए जाएंगे तो उनको सेंटर ऑफ मास कैलकुलेट करना है। तो दिस इज द रिक्वायर्ड कंसेप्ट या दिस इज द रिक्वायर्ड फार्मूला टू कैलकुलेट द सेंटर ऑफ मास ऑफ n पार्टिकल्स। अगर n पार्टिकल्स नहीं है तो जहां तक पार्टिकल है उतने पार्टिकल का समेशन यहाँ से आप इवेल्युएट कर सकते हैं। ओके स्टूडेंट, आई होप दैट यू आर अंडरस्टैंडिंग ऑल दीज इंफॉर्मेशंस क्लियरली। ओके, इफ यू हैव एनी डाउट या any query related to this topic, so you positively write your information or type your information in the comment section positively and then you send. After sending, I will give the appropriate solution of your query in detail. First of all, I will analyze, and after analyzing, I will give the appropriate solution. Okay student, so you follow it positively. Okay, now further I will erase this drawn diagram and also its concept, and then I will solve one numerical, and that numerical will be based on this topic. It means that the concept of this topic I have to utilize in the numerical. Therefore, you concentrate here to understand its application in the numerical. Okay student, so thank you for watching. I'm going to erase this one, and after erasing I will write one numerical, and after that I will apply this concept to evaluate the center of mass of the given particles. Okay, particles means kernel. So I'm going to positively erase it. This formula I am saving because as per requirement I will use, that is sigma I is equal to 1 to n, and variable is mi and ri, divided by, here I will write sigma I is equal to 1 to n, and here I will write xi. So I have to put this formula in the rectangle box. So student need to remember it positively. Each and every student is necessary to remember it positively. Okay, now from here I am going to erase it. Now I will write one numerical and you concentrate here, and that in that numerical I will use this concept to evaluate the center of mass of the given particle. So here I am going to write one numerical and you concentrate here. Now there are two position vector. There are two position vector. Position vectors. Suppose that 3i minus 2j plus k and minus 5i plus 9j minus 2k and also there are two particles have masses 3 kg and 5 kg respectively. Calculate the center of CALCULATE. Calculate the center of mass of these two particles. Okay, so informations I have written in the numerical. So all these informations I will also put in the diagram, and after putting in the diagram I will calculate the center of mass of two particles. One particle has mass 3 kg, that is 3 kg, and second particle which has mass 5 kg. But there are two position vector, one position vector that is available at one center of mass. This is the position vector and this is the position vector at the second mass. So we have to calculate the center of mass of these two particles. Okay, so you concentrate here. First of all I will draw its diagram. After drawing its diagram, and then I will calculate its center of mass. Okay student, so after drawing diagram, then I will also translate all those informations, that is informations about numerical, that is I will translate informations about numerical in Hindi. So student who are reading in Hindi medium, those students can understand its concept. Okay, so first of all I am going to draw here xy plane. Now here I will say there is a origin and its coordinate I can write, that is 0, 0, 0. Now here I am taking the x axis. Here x axis. Now this is the 2D. Here I am saying this is the 2D. This is the y axis. XY plane, that is this blackboard is available in XY plane, that is in 2D, but 3D is outside, one axis will be outside the blackboard. So one axis is along x-axis, other is along y-axis, and z-axis will be same perpendicular to both axes. So duster is the z-axis. Okay. Now here I have taken two position vectors. Suppose that there is a mass, and this mass has um, um, weight, that is 3 kg, that is given in the numerical. So I have to write here positively 3 kg. 3 kg. Okay, this is the mass and it has 3 kg. So this mass I am going to write like this. And its position vector, that is also given, because I will join this mass with a vector, and that vector is given here 3i minus 2j plus k. So that value I am going to write here. So its value, okay, I will write a second object I am also going to show here. This is also object, and which has mass 5 kg, that is given in the numerical. So I will say like this. So both object will be different, because one object has mass 3 kg and second object has mass 5 kg. Now I will join from the center of mass from this object and also from this object. So I will get a straight line. So center of mass will be on the same line. Center of mass will be on the same line. Suppose that I will say this is the center of mass. So this will be center of mass. So I will say this is the point A and this is the point B, and center of mass will be point C, at the point C. So its coordinate I can also write. So I have to write here position vector R1, and this is the position vector R2, and this is the position vector Rn, but I have to calculate its center of mass. So I have to write here R Cm. So here I have to write here, this is the position vector, that is OA, that is R1, and OB, that is R2, and OC, that is the center of mass. I have calculated here center of mass. Now value of R1 I have also write. Now here I am going to explain the vector R1 which is available. I will write here positively. So vector R1, its value is given in the numerical, that is vector 3 vector I minus 2 vector j plus vector k. So here I will write 3 vector I cap minus 2 vector j cap plus vector k cap. Similarly vector R2 I will write vector R2, that is also given in the numerical, that is minus 5 vector I cap minus 5 vector I cap, and then I have to write plus 9 vector j cap plus 9 vector j cap, and then I will write minus 2 vector k cap. So downside I can write 2 vector k cap. Okay, so both vector I have represented in the diagram. Okay students, so all these informations which are available in the question, that is 3 kg of one particle mass and 5 kg second particle mass, I have already represented in the diagram. Now further we have to calculate here center of mass of these two particles. ये दोनों पार्टिकल का जो सेंटर ऑफ मास we have to calculate positively. Okay students, I hope that students who are reading in English medium or in CBSE board, those students can understand this concept in clearly, how we have to calculate, how we have to apply this formula to evaluate its value. That is how we have to calculate the center of mass of these two objects. Okay students, now all these informations I will also translate into Hindi, so students who are reading in Hindi medium, those students can understand its concept in detail. Okay, यहाँ पर कहा गया है कि दो पार्टिकल्स इस न्यूमेरिकल में दिया गया है, लेकिन दोनों पार्टिकल का जो सदिश वेक्टर होता है, सदिश वेक्टर को सदिश वेक्टर है, वो दोनों वेक्टर दिया गया, लेकिन वो सदिश वेक्टर कैसा है, वह एक पोजीशन वेक्टर है। पोजीशन वेक्टर एक ऐसे वेक्टर जो ओरिजिन से पास होते हैं, उन सभी वेक्टरों को हम पोजीशन वेक्टर के नाम से जानते हैं। उस दोनों पोजीशन वेक्टर को दिया गया ऑलरेडी जो होता है इस डायग्राम में वेक्टर r1 और वेक्टर r2 के फॉर्म में हमने असाइन किया उसके वैल्यू को। ओके, नाउ अब कहा गया है कि पॉइंट ए पर जो होता है पोजीशन वेक्टर r1 है, पॉइंट बी पर जो होता है पोजीशन वेक्टर r2 है, लेकिन पॉइंट ए पर जो पार्टिकल है उस पार्टिकल का जो मास है वो मास कितना है, वो 3 kg है, लेकिन पार्टिकल बी पर जो मास है वो 5 kg है। तो कहा गया है कि 3 kg और 5 kg जो द्रव्यमान है जब दोनों को पास में रखा जाता है तो उस केस में वो दोनों द्रव्यमानों का सेंटर ऑफ मास क्या होगा, एक सेंटर ऑफ मास निकले एक पॉइंट होगा, उस पॉइंट के परितः जो होता है दोनों ऑब्जेक्ट जो होता है दोनों पार्टिकल मूव करेगा तो फ्रीली मूव कर सकता है, तो उसको हम सेंटर ऑफ मास कहेंगे। ओके, नाउ तो उस सेंटर ऑफ मास को कैलकुलेट करने के लिए हम इस फार्मूले को यूज करेंगे, मींस इसका पोजीशन वेक्टर ओ ए जिसको वेक्टर आर कहेंगे, ओ बी जिस वेक्टर r2 कहेंगे, जो r1 और r2 वेक्टर जो होता है ऑलरेडी क्वेश्चन में दिया गया, न्यूमेरिकल में दिया गया, उसके वैल्यू को जो होता है यहाँ पर हम r1 में और r2 में क्या किए हैं, असाइन किए। ओके स्टूडेंट, नाउ आई विल इरेज ऑल these informations and then I will give its solution in detail. I hope that all students who are reading in Hindi medium, those students can understand its concept clearly, how we have to calculate the center of mass of these two objects here, these two particles. Okay, now positively I am going to erase the above informations, and after erasing above information, and I will use the concept of how to calculate the center of mass of the given particle, and then we will calculate. After calculating I will explain how I have calculated it. Okay, now positively I am going to erase it, and after erasing I will give the solution of the written question. Okay student, so first of all I will erase, and after erasing the written data, and then I will give its solution, because all information of the question I have already written in the diagram. Okay, now here I have to calculate the center of mass. In first step I have to write here solution. Now here I will write given that all informations which are given in the diagram, so there is no need to write more than one, because in NCERT pattern that is available in one time. So, okay, so that concept we have to follow here. Now here I have to calculate center of mass, so center of mass I have to write like RCM, that is here I will say the vector mass 3 into R1 plus 5 into vector r2 divided by, here I will write 3 plus 5, because here I have to take the summation of position vector into mass plus summation mass into position vector divided by, here m1 plus m2, here there are two mass, so I have written here m1 plus m2. Same formula I have to use here to calculate its value. Now first of all here I will write 3 into the value of r1, that is written here 3 vector I cap minus 2 vector j cap plus vector k cap. Again I will write here 5 the value of vector r2, that is already available here in the bracket. I have to write 5 vector I plus 9 j minus 2 vector k. divided by, I have to write this value 5 plus 3, that will be 8. Okay, now further this 3 is multiplied with this term and also with this term, and this 5 will be multiplied with this term and also with this term. So after multiplying I will add the corresponding coefficient, and then I will get the general center of mass of the given object, that is given objects, that is given particles, in the form of vector. Means vector will have three components, that is x component, y component and z component. From there I can evaluate its value. Okay, now here I am simplifying the written information. So I will multiply 3 into 3, that will be 9 vector I cap. Here minus plus minus, that is 3 through just 6. So here I will write 6 vector j cap and plus 3 into 1, that will be 3 vector k cap. Okay, now and here I will multiply plus into minus, that will be minus 5 5 ja 25 into vector I cap, and then here I will write plus into plus, that will be plus, and 9 4 ja 45 vector j cap. So here I will write vector j cap. So here minus and plus, that will be minus 5 5 2 ja 10. Here I will write vector minus 10 vector j cap, and then I will put here 1 divided by 8, so that is available. Okay, so here it is multiplication. Now I will simplify it. 1 divided by 8 in the bracket I will write, I will calculate here, I will summarize the coefficient of I and coefficient of I. So I will write here 9 minus 25 vector I cap. Similarly I will say here the coefficient of j, here is minus 6 and here is plus 45, and then I will write here vector j cap. Similarly I will add coefficient of k, that is coefficient of k is available here 3 and here is minus 10, so I can write here 3 minus 10. In the bracket I have to write 3 minus 10. Okay, so this is the required way, but here I will also write the vector k cap. Okay, so according to this way I have to simplify the given data. Okay, so vector RCM, that is center of mass. CM stands for center of mass. So center of mass I have calculated in the form of vector, that is position vectors. There are 2 position vectors given in the numerical. So its center of mass I will also calculate in the form of vectors. So x center of mass of x coordinate I can write, that is the coefficient of a vector I cap, and center of mass of y component, that is vector j cap, coefficient of vector j cap, and similarly coefficient of vector j cap will be the center of mass of z component, that is ZCM. Okay, so this is the required concept here, this is the required way to calculate its value. Now further I am also going to summarize its value, that is RCM. Here I have to write 1 by 8. So here I have written 1 by 8, in the bracket I have to write 25, 20, here is plus 9 and minus 25, so 16. So I will subtract 16 vector I cap and then here I will write that is 39 vector j cap, and then here I will write 10 minus plus 3, 10 minus 10 plus 3, that will be minus 7 vector k cap. Okay, so this is the answer. This is the answer of my question. Okay, so x coordinate will be x cm will be minus 16, y cm will be plus 39, and z cm will be minus 7. So this is the required answer in the vector form. I have calculated the center of mass of given two particles in the vector form, and separately I can get its value xcm. Xcm will be minus 16 divided by 8, and ycm which is equal to 39 divided by 8, and zcm which is equal to minus 7 divided by 8. So that will be in a coordinate form. Center of mass, that will be in coordinate form. Okay student, I hope that you are understanding all the informations clearly. Therefore you like this live video, and also you share this live video with your colleagues, friends and students, so that they can also update their knowledge on this topic. Okay, and simultaneously you also subscribe this education channel more and more. Okay, now all this concept, that is solution of this question, I will translate into Hindi, so students who are reading in Hindi medium, those students can understand this concept in detail. Okay student, now so all informations of the question I have written in the diagram. Now there are two particles. यहाँ पर दो बिंदु है, एक बिंदु A है, दूसरा बिंदु B है, और इस बिंदु पर जो 3 kg का द्रव्यमान है और बी बिंदु पर 5 kg का द्रव्यमान है, इसका सेंटर ऑफ मास मैंने एज्यूम किया है इस पॉइंट पे है, और इसका सेंटर ऑफ मास इस पॉइंट पे है। दोनों पॉइंट को जब हम ज्वाइन किए हैं तो एक स्ट्रेट लाइन पाए, एक सीधी रेखा को हमने ऑब्टेन किया। उसी सीधी रेखा पर जो होता है सेंटर ऑफ मास जो होता है, या तो ऑब्जेक्ट बी के करीब होगा या तो ऑब्जेक्ट ए के करीब होगा, वस्तु ए के करीब या वस्तु बी के करीब होगा, लेकिन हमको मालूम नहीं है, इसलिए एज्यूम कर लिए कि वो सेंटर ऑफ मास जो होता है इसी लाइन पर किसी बिंदु पर होगा। तो उस सेंटर ऑफ मास को कैलकुलेट करने के लिए हम जानते हैं कि ये दिया गया पोजीशन वेक्टर के फॉर्म में जो होता है क्वेश्चन में दिया गया वेक्टर के रूप में, तो उस हमने एक्स कोऑर्डिनेट और एक्स एक्सिस वाई एक्सिस को मैंने ड्रा किया, दैट इज एक्स वाई प्लेन को मैंने क्रिएट किया। उसको क्रिएट करने के बाद से जो होता है वो पोजीशन वेक्टर दिया है, तो ओरिजिन से जो होता है उस पॉइंट को हमने ज्वाइन किया, वो पोजीशन वेक्टर को रिप्रेजेंट करेगा। इस तरीके से दोनों पोजीशन ओ ए और ओ बी पोजीशन वेक्टर को हमने लिखा, उस पोजीशन वेक्टर के वैल्यू को यहाँ पर असाइन किया R1 और R2 में। उसके बाद से एक जनरल पोजीशन वेक्टर ओ सी हमने लिया, जिसको RCM से हमने रिप्रेजेंट किया। RCM जो होता है वेक्टर फॉर्म में इस दोनों मास का, इस दोनों द्रव्यमानों का वो केंद्र हो गया, द्रव्यमान केंद्र होगा। उस द्रव्यमान केंद्र को कैलकुलेट करने के लिए हम जो एबव फार्मूला को सेव किए, जो ऑलरेडी हम अभी प्रीवियस स्टेज में इसको एक्सप्लेन किए थे, उस फार्मूले से जो होता है हम उस सेंटर ऑफ मास को कैलकुलेट कर सकते हैं। तो उसको कैलकुलेट करने के लिए हमने ऑलरेडी यहाँ पर लिखा था कि सेंटर ऑफ मास जो होता है, जो 3 kg का द्रव्यमान होता है उसको R1 वेक्टर से मल्टीप्लाई किए प्लस, और 5 kg का द्रव्यमान हो R2 वेक्टर से मल्टीप्लाई किया, और दोनों द्रव्यमानों का सम हमने लिखा है इस फार्मूले से और इस फार्मूले से। ओके, उसको लिखने के बाद से इस 3 को जो होता है इस पोजीशन वेक्टर दिया गया, उस पोजीशन वेक्टर को यहाँ पर लिखे हैं। लिखने के बाद से प्रत्येक टर्म में जो होता है यहाँ पर 3 से मल्टीप्लाई किए हैं, तीनों वेक्टर में एक्स एक्सिस, वाई एक्सिस और जेड एक्सिस के अलॉन्ग मल्टीप्लाई करके उन वैल्यू को यहाँ पर लिखे हैं। और इसमें जो होता है ये वेक्टर पोजीशन वेक्टर दिया है, इसमें प्रत्येक टर्म में 5 से मल्टीप्लाई करके उसको यहाँ पर लिखे हैं। उसके बाद से एक्स जो वेक्टर एक्स एक्सिस के अलॉन्ग है उस वेक्टर को के गुणांक को हिंदी में गुणांक कहते हैं, इंग्लिश में कोफिशिएंट के नाम से जानते हैं, उसको इकट्ठा किए हैं, उसको सिंप्लीफाई किए हैं। जो यहाँ पर जो होता है एक प्लस साइन होता है, एक माइनस साइन होता है, इसका कंसेप्ट होता है यहाँ पर घटेगा। घटेगा मतलब सब्सट्रैक्शन होगा। तो हम बड़े अंक में से जो होता है छोटे अंक को घटा देते हैं, जो बड़ा अंक होता है उस बड़े अंक का साइन हम सब्स्टिट्यूट करते हैं। 25 में से 9 को घटाया 16 मिला, और 16 मिला, और ये इसमें हम देख रहे हैं बड़ा अंक जो होता है 25 है, इसका साइन जो होता है निगेटिव है, इसलिए हमने निगेटिव सब्स्टिट्यूट किया। इसी तरीके से यहाँ पर और यहाँ पर उस कॉन्सेप्ट को यूज करके हमने फाइंड आउट किया उस पोजीशन वेक्टर को, जो पोजीशन वेक्टर आरसीएम है उस पोजीशन वेक्टर को हमने फाइंड आउट किया। वही जो होता है उन दोनों पार्टिकल का मतलब ये दोनों वस्तु या कण का जो होता है सेंटर ऑफ मास होता है, जिसको द्रव्यमान केंद्र के नाम से जानते हैं। तो ये आरसीएम जो होता है वेक्टर के फॉर्म में दिया गया। अगर हम कहेंगे एक्ससीएम क्या हो गया, एक्स कोऑर्डिनेट का जो सेंटर ऑफ मास क्या होगा, तो हम कहेंगे -16/8, और वाईसीएम जो होता है 39/8, और जेडसीएम जो होता है -7/8 होगा। According to this way, I have solved the written question with the help of diagram. Okay, student. So you have to positively understand all the informations clearly. अगर आप इस सॉल्यूशन को आप क्लियरली समझ रहे हैं तो इस वीडियो को ज़्यादा से ज़्यादा लाइक करें, शेयर करें अपने कलीग के साथ, फ्रेंड्स के साथ और विद्यार्थियों के साथ, ताकि उनका भी नॉलेज इस पॉइंट पर अपडेट और डेवलप हो सके। और साथ ही साथ इस वीडियो को ज़्यादा से ज़्यादा सब्सक्राइब करें। ओके स्टूडेंट, थैंक यू फॉर वाचिंग दिस लाइव वीडियो। आई विल मीट विथ यू tomorrow on the same time, that is 30 minutes past to 7 o'clock to 30 minutes past to 8 o'clock. One information I am going to tell you, and you have to understand positively. Always I will be there on the same time, that is 30 minutes past to 7 o'clock to 30 minutes past to 8 o'clock. But concept and numerical will take too much time slot, so I will give time slot after completing the topic and also its numerical solution, and then I will terminate the communication with you. Okay student, so thank you for watching this live video. I will meet with you on the same time tomorrow. Jai Hind, Rana sir.